All right, we've got another collaboration project. This is one that I'm doing for weld.com, the guys over there. And we've got 3 pieces here to machine. And what they're building is a guided test machine. And this is going to be for bending test coupons, test weld coupons. And what they're going to be doing is they'll have 2 of these pieces here that's going to be on the bottom, and they will roll. We're going to have bearings inside there, and then the top piece we're going to mill a flat on this one, and it'll be welded to a piece of square stock that's attached to a hydraulic ram. So what will happen is this will push down, the coupon will be sitting in there, your flat piece will be sitting there, and then this will come down and bend it. So we are going to be making the rollers for them, and they supplied the print on all dimensions right there, the length. We're going to be making it 2.5 inches long, and then it'll be counterbored on each end for the bearing. All right, pretty simple, straightforward machining. And then we've got one more piece. This is going to be for the fixed roller, which will be welded to the piece of flat bar. So we're just going to set it up and mill it so that it's got a flat and got to face it to length. So that one's pretty simple, quick and easy to do. I might even upset some folks and go over to the shaper and use the shaper to cut the flat on there. So that's it. Pretty easy stuff. And I've had this for a little while, so I'll need to go ahead and try to get it knocked out so that they can get to finish their fabrication of the bending machine there. First op we're going to do is go ahead and get them all faced to the proper 2.5 inch end length there. And my edge chuck parallels won't actually fit in the 6 jaw right here because it's closing down too small to be able to use that. So I'm just going to simply use a parallel like this, just a regular milling machine parallel for your mill vise. I'm just going to lay it in there before we do each one, and we'll just push the piece back against that parallel, snug up the chuck, and I'll slide it back out, and I'll do that every time. So what we'll do is just make one cut across all 3, and then we'll flip them around and then finish them to length. So we'll just do that. We'll make one cut across it just like so, and then we're going to stick our parallel in there again. And then I evenly tighten the scroll chucks like that. All right. Ready to make another cut. Got one side of all 3 of them faced now. I'm just going to take a rough measurement. So we're still right at 3 inches, just a little bit over 3 inches. We got a crooked cut there on that end, so they're not going to measure all equally. But I'll just repeat the exact process that we just did with the parallel here. And just slide them in. And what I'll probably do is go ahead and forgot to take my parallel out there. I was getting ahead of myself. What I was saying, since I've got a 1/2 inch to take off this, I can't take all that at once anyway. I'm going to get this one close. I'll pull it back out, measure it, make sure we get the first one on an exact length that we want, and then I'll have this 0 set right here, and then I won't touch it. I'll know I can come into this 0 for the other 2. All right. taking 16th passes across here. All right, this first one, we've got it near our length that we want it. Got a little over. I've just been using my hook scale to get me close. So, using the calipers, says that we've got 25 thousandths to come off of it. So this is going to be our final 0 set right here. We'll put our parallel back in there. Lightly push it against the parallel. Make sure we pull the parallel out that time. All right. So I'm going to move it over another 25 on the dial right here, and I'm going to reset this one to 0. And what I'll do is I'll put I got another mag back like this that I'm going to put on the other side to use to count down to our 0 here. Here's our first one that we finished to size. And you can see using the calipers and the dial indicator, I'm within 1/1000ths. Not that that dimension is all that critical, but we know we hit it within 1/1000ths there using a caliper anyway. So just going to go ahead and repeat these methods. As we said, we'll go ahead and stick our next one in there. Saw cut out. And I just got to get another indicator set up on the other side of the carriage here. Touched off the end apart, got this preloaded, set to a 0, so we'll just make our 16th offset and use this to move it that way. Alright, so we got all of our parts face to length. I went ahead and chamfered them also. So on 2 of them, we're going to go ahead and put our through hole in there. And what we'll do is we'll pilot it with a 3/8 drill through there. And then we're going to drill it with a, let's see, it was a 47/64. I just put a fresh grind on that using the Lyle drill grinder. So that'll just be a drilled through hole, and then we'll counterbore each side for the bearing. Got both of our 3/8 holes through there, so we're going to go ahead and go with our 47/64 now. Warm. Not too bad. The hole looks pretty good. Go ahead and finish out this second one now. Run 350 RPM. All right, for our boring tool today, we're going to be using the Micro 100 Micro Quick tool holding system here. And I've got this little boring bar we're going to use. We're running the 1/2 inch shank tools. This is the one, you push it in there and that pin that's in the back right here actually squares the tool up. And then you tighten the set screw and it just seats it in there and keeps it in place. This is the mic that I'm going to use today to get the bearing journals bored to size. This was my granddad's. You can actually see his initials right there, JAB. This is 1 to 2 internal micrometer right there. So I'm going to inspect it and make sure that it's still on. I've got this Ringmaster ring gauge here that is the perfect size for that mic. You can see the size right there, 1.1250. These are standardized. You know, it's so it went out of calibration back in what, 12, but probably still good. So we're going to go ahead and I'm just going to very lightly clamp it in the smooth jaw reed right there just to hold it in place. We'll go in here with our mic. I don't have any rock there and it's sliding out. So we want 1.125. It looks like we're right there on it, maybe a couple of tenths shy. Let me try it again and see if I got it right there. When I do this, I'm trying not to look at this zero. I'm not trying to line it up because I want it to line up. I want to get the right feel for the mic inside this ring gauge right here, or standard. And I can move it in and out right there. Let's see what we got that time. So it looks like it's pretty close to zero that time. We may be 1/10 off, but we are pretty good. We're going to go ahead and call this one ready to roll. So we'll go back to the lathe and start getting our piece board for our bearings now. All right, we've already got a depth established, so we're going to go 9.47 millimeter deep, or 373 thousandths, right at 3/8. We are ready to go here. Let's see how our micro tool is going to do. Taking 50 thousandths cuts right here. Such a short journal, I'm not overly concerned about that stringy chip, you know, because we don't really have much chip grooving profile ground on that tool. But it looks like it's doing a good job, so I'll just take some cuts like that to get it about down there to size. Tool sounds nice. I may need to get in there and pull those chips out, but they are going up inside the spindle. So yeah, we're going to be close to 950. Still got a little ways to go here. All right, we should be sneaking up on our finish here. Let's see about where we're at. So it looks like we're at 1 inch 103. So it looks like we got 22 to go. We want to finish it at 1.124 to 1.124 and a half. We want just a little bit of interference so that the bearings actually press in there. So a little bit to come out. think I'll split it. We're just going to do a 10/1000 cut here. We'll mic it and then we'll finish it, put it on our finished size. Just want to get rid of the little fuzzy chips out of there so you're not micing on them. Alright, let's see what we're getting this time. We'll take a couple measurements just to be sure that we know where we're at. So just trying to get the mic squared up both ways. Alright, looks like we're gonna have 10/11 thousandths. Yep, looks like we got 11 thousandths to bring us on our size that we want. So let's go ahead and take it. It'll be right there, maybe a couple tenths off. And I'm going to go ahead and clean up that face while we're in there. I left myself 4 thousandths to back face it. Like that right there. So let's go ahead and give it a check again. Get my chips out of it. Let's see if we hit our size. Looks like we hit it right on 124, 1.124. Perfect. All right. So that's going to work for our interference fit there. The only thing left to do, we need to go ahead and put a chamfer on there. We need to chamfer this and that inner bore so to get rid of that sharp edge. All right, we swapped out my boring bar for a threading tool and we got it kicked around a little bit of an angle. We'll go in there and use that threading tool to break that edge. I'm actually contacting Micro. I'm looking at their catalog to see if they make an actual chamfering tool so that we have like a 45-degree angle where you can just stick it in there, leave your tool set where it's at to be able to come in and break those edges. Just want to knock the sharp corners off is all we're doing. Just like that. So we'll go ahead and take this guy back out. One last little thing, we'll take this gray Scotch-Brite and just kind of soften up that chamfered corner, just like that. Clean the face up, make it look nice and pretty. All right. And that is finished up right there. So, not going to bore you with repeat steps. What we're going to do is take the part out. We're going to flip it around, and I'm going to keep doing the same thing 3 more times that I just showed you right there. So I'm going to bring it back whenever we get to the other. This piece here is the one that we're going to mill the flat on, so I'll bring you back whenever we get to the shaper, okay? I'm just getting to the last hole. I got to flip it around, but I wanted to show, see, another benefit of having these types of small carbide boring tools is you can easily touch them up yourself. So I noticed on this last one, it was starting to squeak a little bit more on me as I was finishing it out, and after I finished it, I pulled it out, and I could tell that the corner had starting to get burned a little bit. You know, it was rolling over, so I went over to the Baldor carbide grinder and touched up this edge. I just went against this face to bring this edge further in. I didn't touch this face here or the top. So I just relieved this and then broke the corner again. So just one of the benefits of having that solid carbide. You can go over there and, you know, if it gets dull, which is usually just a corner, you can go touch it up yourself and then keep on going. We got you over here on the big date press, and we're going to go ahead and press the bearings in. I did confirm with Jason if he wanted these pressed in, and he said, yeah, that'd be great. So let's go ahead and push them in there. Bring Bring the ram down to kind of square the bearing up. Doesn't take much, and there it is. That looks like some trash on the bottom of the ram. Let me get a rag and just kind of wipe that a little bit. I thought I cleaned it off. I think it's got a little bit of rust down there on the bottom. Easy does it. All right, one more to go. That one I actually used the hand wheel to press it in there. This one ended up being a 1/2 thousandths bigger than the other holes there. I knew there was one that was a little bit more loose than the others. All right. Okay, there we go. Those two are done, finished up. So now we can go ahead and take our third piece to the shaper and get that flat cut on it. All right, we're set up in the shaper vise, and what I want to do is just establish a top dead center touch off right there. I'm real close, so I'm going to take the table and just kind of run it back and forth. Move it down a couple thousandths at a time and see if we get a touch off there. All right, there we go. It's touching it. Yep, we got a little touch right there. So we'll be taking a total of 1/2 inch off this right there. We'll probably just do it in 2 cuts. I'll just dial down a 1/4, and then we'll measure it, and then we'll take whatever we need to finish it out in the second cut. All right, here we go. Do a 20,000 step over, 1/4 inch depth of cut. See how nice and easy that was? Nothing to it. We'll move it over so we can get a measurement on it. This isn't a super critical dimension here just because we're going to be welding that to the, or they're going to be welding it to a bar. But their spec was 1 inch on the thickness here. Trying to get the radius there on the bottom, make sure we're centered up on it. All right, looks like we got 200, 25, 35, 40, so we've got 242 to come off for our second cut. All right, we got our depth set. We'll use some of our dark cutting oil here. And we are ready to go. pretty good. So looking like I'm getting $9.99. So we're right there where we need to be. The print actually calls for .998 on the thickness, but not really hurting anything right there. So we're good here. Just got to take it out, deburr the corners, and we'll be finished up. All right, guys. Well, we're finished up with all of the parts for weld.com. Got our two rollers there finished up with our bearings, and then this is our part that we just cut in the shaper. I always love the way those shaper finishes look. So I'm looking forward to seeing their build on this test bender unit that they're fabricating for test coupons. So be sure to go over to check out their channel, weld.com. They always put out some nice informative videos, and I had fun collaborating with them on this project. So we're going to get it packaged up and send out their way, and I hopefully you enjoyed the video. We'll see you on the next one.